let's get started. It is awesome to have two Carnegie Mellon alums from the database group here to tell us about all the fun stuff they are doing in Oracle 23 AI on concurrency control and consistency. And these are topics that are as old as the field of database systems, but it's fun and interesting to see all the new innovations that are happening. So Kishi is a director in the transactions group, and of course, a 2013 alum from here. And Akshay Kulkarni is in that same group. He's a manager there, also a 2017 alum. So really delighted to welcome you virtually to campus. We hope to see you on campus in person sometime. Andy unfortunately can't make it today, but he's here, and I'm sure he's going to watch this video. So with that, we can get started, and you guys can take over.
Sounds good. Thanks a lot, Jignesh. First of all, for giving us opportunity, to speak with a bunch of other database enthusiasts. Right. So it's always good to be coming back to Carnegie Mellon, whether it's physically or virtually. Right. But thanks again. Right. So today in this talk, guys, we'll be talking about Oracle transactions. And some of the new things that we did, in our latest version of the database 23 AI. Okay. So we'll be talking about 4 features. So I'll be talking about the first 2, which is replication of JSON relational duality, and the second one, is lock-free reservations. And Akshay after that would take over, and we'll talk about, he'll talk about sessionless transactions, and value-based concurrency control. So 4 things we'll be covering in the talk today. Just the safe harbor statement. Okay, so the first thing is replication of your business objects with JSON relational duality. So how do we consistently replicate the business objects, as JSON documents using JSON relational duality? So first, a bit of a background. So I have about 4 slides on this, right? So let's quickly go over it. For folks who know about JSON relational duality, great, right? But for folks who don't know, I'll try to quickly walk you through, on it. So, so in the application land, right, you have application objects, right? We also call them business objects because all the enterprise apps, right, they call them business objects. So in this example, we have an attendee schedule with all the fields in it. So you can think of it like a Java or Python object, which has all these fields, and it's an array of sessions. Which is connected to the session object with all the fields, and session itself has an array of speakers. So this is on the application land, but on the database land, things look a bit different, especially on the relational side, where the data model is tables, it's rows and columns, and all of those are connected through relationships, through one-to-many or many-to-one or many-to-many, right? So we see that the session table, speaker table, and and the other tables are connected, on which you'll have either some layer, like an ORM layer, which will be backing your, your business objects. So to store business objects, right, there are a couple of ways to do it. Either you can, store them, on relational format, or you can store them on document storage. But we realized, hey, that with document storage, it's very simple to get started. Right? So when the use case complexity is very low, then the benefits are huge because of quicker development. But as the use case complexity goes up, then the benefits, we think that they diminish because over there the relational model is far superior, at scale when your data is pretty complex. Right? So that's some problem with the document storage, and that's why we have this new concept of JSON relational duality, where you can access the data the same way as you would do it in a document store, through JSON objects. But the data is managed natively, as rows and columns, right? So you can think of it that the access layer is JSON, but the storage is actually rows and columns, and we handle in the database, we handle your, your reads and writes to the JSON Okay, and we would shred them into rows and tables ourselves. So the benefits are no duplicates because again, your data is normalized. Your access can be SQL or JSON. Uh, and your JSON objects, we would allow those to be mapped into complex objects with many tables. And we have this new concurrency control mode, which we'll see later, uh, that it helps prevent lost writes. And it eliminates the need of ORMs, which have been especially there, and there are like so many pros and cons of them, but it eliminates the ORM frameworks. So moving on to some example of it. Um, so the JSON relational duality is nothing but a JSON view on top of the data that you want to include in the final JSON document that you want your application to see. So in this case, so we have this example like GraphQL syntax with which you can, create this duality view called attendee schedule with these tables like attendee table, which has these columns, and on the left hand side, there are these fields, and similarly, you can just map this attendee via the PKFK relations with the attendee sessions, the session and speakers, and all these are tables basically, right? And you're just creating a view on top of it. So this more or less becomes your business object, which will be surfaced back to the application. So we also have this new, we have the optimistic concurrency control mode with JSON relational duality that when the application would get the document from the database, it also gets this thing called the E tag, which is nothing but the hash of your data in the JSON document. And when it wants to make a change to this document, this change is made in the application, and it's sent back with the same E tag. And the database figures out um, whether the E tag has been changed by any other transaction or not. So if a transaction had sneaked in the middle of this reads and writes, then the write would be rejected, right? Because there would be an E tag mismatch. And in this mode, we make sure that there are no lost writes because we're checking for write conflicts. Okay, so far we have covered, like some background about, JSON relational duality. So my team was tasked with working on the replication aspect of it. That hey, how do we replicate the data, from Oracle, to other targets like Oracle, like MongoDB, and a bunch of other databases, right? So that's basically, like logical replication, of your data to other databases, right? So let's start looking into that next. Okay.
Kishi, are you going to
Yeah.
talk about any more details about the lock modes before going into replication in the previous slide?
So if you have any questions, we can talk. But hey, this is a concurrency control mode that we have today. And with respect to the locking modes, so underneath we use the row locks itself, if that helps, right? So we lock the rows, and not the whole object.
Got it. So the lock all the rows in the shredded tabular representation whenever you get. So get is considered a read, and then you'll do upgrade that to a write when you have a put of just presumably just the rows that were changed, unless there was some structural change to the JSON object.
Yes.
Got it.
So, so if you so in this example, if you had changed, let's say something in the session field, over here, right? So we lock the session row when we do the update, but we make sure the whole object's hash was the same when you had read it.
Got it.
Then we update the session row. Yeah.
Got it. So do you have anything like an intentional lock if the application knows that I'm very likely going to make a change that can grab something implicitly or explicitly greater than read locks on the get doc call that it makes?
Yeah. So we don't have intent mode locks, right? So we do use intent mode locking, like for other features, right? But not for this feature so far.
Got it. Okay. Thank you. Appreciate that.
So yeah, so we'll see more of locking and I guess like transactional stuff going forward. So yeah, so the requirement is that hey, that you have an application which runs on a relational database, okay, and you know we want to replicate, the business objects, out of a relational database. Okay, so today, how do people do it, right? So they have these change data capture tools, okay, which can send the transaction logs, but only at a row level, right? So only for row level changes does it replicate, your data, but it does not replicate the business object. So for example, in the previous case, if you modify the session, only the session row, is replicated out, but the whole object that we saw, right, would not have been replicated today. And developers today, and big enterprises, right, the way they solve that problem, is through having this outbox table, right, where you would figure out that, hey, that some row was modified, and you will construct this JSON, in the database, either via triggers, right? You figure out all the other rows, like you would read them and write a JSON object to this outbox table in the database. Uh, and the change data capture tool would read this JSON object, and would send it to the target, as JSON format. So this is also called the transaction log tailing pattern. Um, but as you can see that there's a lot of work involved, for the developer, over here. So they have to maintain this outbox table. They have to figure out, hey, that if this row was changed, then which objects or which particular rows I need to read, to construct my final business object. So this is a problem which is seen outside, where people are trying to replicate, the business objects. Um, so um, so the way we solve it, um, so the same apps. So instead of working with relational formats, you're working with with objects, okay, which are JSON relational duality objects, right? So you write JSON objects to the Oracle database, which is storing JSON, and tables, right? So stored as relational, but your transaction log now, instead of replicating rows, the database itself is replicating JSON. We have our own internal, efficient format called the OSON, which is Oracle JSON. Uh, so we replicate OSON outside of the database, which is given to a replication tool like Oracle Golden Gate, which would transmit the JSON logs to its streaming channels, right, which are eventually consumed by the data producers, and the end user, like you have analytic dashboards and so on, right, which would be refreshed in real time. So, um, so the benefit of replicating JSON, over here at step 4, is that, so now anybody can consume this JSON format, right? So it's a standard format which is known by all databases, right? So anybody now can consume it. And since it's JSON, it can be like transformed by any available tools out there. So if you want to write it back to relational, you can do that. If you want to keep it normalized, you can do that. If you want to update your keys in a Redis database, you can do that, right? All with JSON. So today we'll talk about like just that part. That how we make sure that the log is that we are able to consistently read the objects, the JSON objects from a duality view, and put it in this transaction log for replication. So let's go over it, right? So we have a couple of challenges, if you have to start implementing it inside the database. Okay. So if you recall this OCC, right, concurrency, control mode, which I talked about with the E tags, right? So at DML time, since we only modify the row, uh, inside the modified object, right? So in the previous example, it was a session row that's modified. We make sure that there are no lost writes, but hey, but it's only, that row that's changed. So now, right, so before commit, you can have another conflicting relational update, that comes in, because Oracle allows both relational updates, and updates on duality views, which can change the unmodified parts, of the object. So, so by that, what I mean is, with the same example, transaction one comes in, it updates this duality view, but it changes the company, which would modify the attendee table, right? So that row, would be locked. through the duality view update, right? So this gets locked. But transaction two can come in, and update the session time with a relational update, and that's allowed in the Oracle, the concurrency control mode, which I had mentioned earlier. So this is a challenge for us because now, right? So if at the time of commit or at the time of DML, we wanted to read this object and throw it into the transaction log, we cannot do that because somebody else can come in, and update this time and commit before you, which would get a commit timestamp lower than you. So you must have included that guy's change, which you did not. Right. So this is a challenge we have to, solve. Um, the second
So
challenge.
one quick clarification question on just the previous slide where
Yeah.
you had two different transactions. So what's the uh, guarantee that you give to each transaction? Is it just that write conflicts
Yeah.
are guaranteed, or is there some notion of repeatable read for the entire JSON object? Like transaction two might have read the company field and then do the update and read the company field again. So it may not get repeatable read. Is that allowed, or what's the isolation level that you get in this dual view?
Yes. So the isolation level which you get, it's called consistent reads, in Oracle.
Okay,
Right. It's also in one of the papers, I believe, like I guess it's a paper on isolation levels, right? I'm forgetting the name, but yeah. But it's consistent read, right? It's not repeatable read, right? So it's lesser than repeatable read, um, right? So you can have a case where the session reads an object, if someone else can modify and commit the transaction, and this same session, if it repeats the read, you'll see, committed data from another transaction. So you can see that. But
great.
here, what we are doing is we are preventing the write conflicts at the time of DML to make sure, hey, then that at least a time when we're doing the DML, again, nobody else has sneaked in.
Yeah.
Okay. And you only change the object which you wanted to, I guess only the part of the object which you want to change, right? Not the whole object is locked.
And do you treat schema changes in a different way, or it's the same DML path as an update to an existing field in the JSON object? So if I were to change the schema and maybe uh, just making up an example, flatten out the speaker or something like that, uh, would you then essentially grab a right lock on the entire JSON object? Is that how that would work?
Yeah. So for DDLs and DML synchronization, or DDL synchronization, right? So we have, other mechanisms. So in Oracle, we have two mechanisms, like called the offline, and the online. So offline would stop the transactions, when a DDL is running, right? So far we have that mechanism over here. So if a DDL was running to change the shape of the duality view, um, we would block it, until all the transactions are cleared. Okay. We also have this online mode where the transactions can run concurrently with the DDLs, which we have not implemented so far, right? But it's in our roadmap.
Great. Thank you.
So the second problem is, the fan out, right? So now imagine you have an orders duality view, right? So order items and products, right? So that typical schema, and in that, if you change the product row, like it can end up changing a lot of orders, right? For example, if you changed, your burger name, right, from, like crispy chicken, to McCrispy, someday, then a bunch of orders have to be updated, right? So this is again, like a theoretical example, right? In practice, you may not be doing this, but hey, it leads to, like several orders being changed. So now, the database has to gather all the order objects that were affected due to this product row change, right? So this is another challenge in the database. So how do we fix it? So I have a single slide on it, by the way, right, which is pretty dense. Feel free to ask questions. So at the time of DML, right, we track all the modified keys. So for example, if you change the product row, we track the product key. If you change the session row, we change the session's ID, right? So all the keys are tracked. Then, then at pre-commit time, when a transaction is just about to commit, we would compute all the fan out of the objects, or the closure as we call it. So to compute this closure, we perform a join query, to get all the affected order objects given a product, ID. So think of it like that you're doing a walk back, right? So you're given a product row, and you want to reach all the orders, right? So it's a simple join where you can run a select query, and join order items and product, and get all the orders uh, given a key, right? From this, we can get the fan out, right? The second thing is serializing transactions, handling phantoms, right? So, so since I mentioned about the synchronization challenge, a couple of slides back, so how do we address that? So we would lock all the affected, order objects, in this example, right? So once all the order objects are locked, there is still a case where you can have a new order being inserted, which refers to an existing product, right? So how do you capture that phantom insert, and lock it? So we have two ways of dealing with that. Okay. So the first way is that we lock, all the phantom, order objects. So in Oracle, we have, these read modes where we can see, like even uncommitted data, right? So we leverage that mode, of read, um, and we would lock, all the phantom, order objects. The second thing that we do is um, we also wait for conflicting transactions that are holding the row locks. Okay. So, so what I mean, so if a new order is being inserted, um, which has a product row in it, but the product row is also modified. So the order transaction, right? It looks at, the whole order object. It sees, hey, that somebody is holding a row lock, on the product key. So I need to wait for that guy. So if you do these two things, then you will be able to capture the phantom order insert case, right? So with this, we are able to serialize these transactions for a short duration at commit time so that, so after this, you can read all the objects in consistent read mode in Oracle, and dump those to the transaction log, right? So with this, it gives you the impression that you had locked all the duality view objects, you know, and you're consistently, like dumping that data, to the transaction log for replication, so that on the target, like you won't have any anomalies like lost writes, or any other anomaly basically. So yeah, so this is the algorithm basically, right? Which is used to consistently replicate, the objects. So again, this may be a bit dense, right? So we can take on some more questions, maybe now or towards the end. Um, so we have more details on JSON relational, duality coming out soon. So it's in our Sigma 2025 paper, right? Since it's not been published yet, right? So I cannot, I guess, discuss that over here, but you'll find more details over there. Okay.
Yeah, I think Tirthankar and others gave a talk on that last semester. So I
Yeah.
think people here are pretty familiar with it. It's a nice piece of work.
Okay. Okay. Yeah. I mean, good to know. So yeah. So that's one. Okay. So now, since we are pretty much right 26. Okay. Okay. I'll try to speed up a bit. Okay. So that was the first, like first big thing, which happened in transactions. Right. So what's next? Right. Lock-free reservation. Right. So it eliminates the hotspots, on your frequently updated data. Right. So what's the case? Right. The case is that you have a new iPhone release, that's coming up, right? And everybody wants to buy the new iPhone. At 12 p.m. and like 12 a.m., right? Everybody sits on their, I guess, laptop and clicks and tries to order it, right? So everybody is hitting, some supply of iPhones row, right? And try to reserve an iPhone, for themselves, right? So what happens, inside the database, right, is that if you had a few rows which were keeping track keeping track of that limited quantity, then those rows, get pounded by all the sessions, and you'll have hotspots, a row lock contention. Um, and as I said, right, that the inventory, for popular items, in an e-commerce store, is a very common case, that you would see in the field, for contention, right? So what are the, current approaches, to address hotspots? So you have this, optimistic approach which apps take today, where first you check for the availability of QoH, which is quantity on hand, which is how much, quantity, of an item do you have? So you do a select. So select one from this, where item name is this, and quantity is greater than some amount. So now you know, hey, that I have enough quantity, and then, at transaction commit time, you would actually check the QoH again, and you would perform the update. So you do this update, set, quantity equal to quantity less than the required amount that you need in your session, where the this, and QoH is this, right? So this is what we typically see, being done in applications, but it has drawbacks, right? So the drawbacks is that at commit time, uh, you know, since you're trying to do the update, right, it may not go through because you may not have enough quantity, by then. Because if everybody reads the same quantity, and is happy at the same time, then at the time of commit, I guess, only a few people would get through, and the others, would fail. So it leads to, transactions abort at the very end of a transaction, okay, which would lead to a bad user experience. So think about it that you were able to add your new iPhone to the cart, but once you went, to click on place order, right? So at that time it says, hey, we don't have any iPhone anymore, right? So you spent a bunch of time, like just doing nothing. So it spoils your user experience. It's wasted work because now, I mean, like this transaction may have been long running. So it's going to take a bunch of time to roll back. Um, so it's just wasted work. Okay. Right. So the solution we have is lock-free, reservations. So we introduce a column level property called reservable, which can be used for certain, aggregate types, for example, numbers. And we also allow you to specify, this check constraint um, on that column. So what we do internally is we have a journal where we keep track of all the reservations that the app that the session wants to do, right? So we'll see in an example, in the next slide. Um, so what we do, is at the time of the update of the row, we don't actually lock the base table rows, which reduces, this locking overhead, at the time of the update. But we still keep the reservation around. Okay. So, so if any new reservations are coming in, we actually consult this new data structure called the journal to check, hey, that can this reservation be satisfied, and can your constraint be satisfied as well? And we reject any new reservation requests that come in, which would lead, to failure in your reservation requests, right? Um, so we don't roll back, the transaction. So, and we only acquire the locks during the transaction commit, which is for a very short duration, to reduce the locking overhead for between the time, the DML starts and the commit happens. Okay. Right, so let's.
So, quick question on that. Presumably, you can allow for over reservation over the required amount. So, by specifying some constraints.
So over the required amount, right? So
Yeah,
I'm
so
not.
let's say I have just 10 units, but I do want to allow 110 reservations and only eventually, because someone might abandon a cart, right? So sounds like you can specify a constraint like that because you had
Yeah,
that constraint in the previous slide. Okay,
correct, correct, correct. So yeah, so you can specify a constraint where you can specify, hey, that my quantity, like should not be greater than 1,000, right? When you actually have, like 100 items, to be sold.
got it. Okay, cool. And can that constraint be a function of some data value in the database, or it has to be independent of it?
So I'm not sure about that right now, right? But I can get back to you on that.
Okay,
Right. So maybe we can. Okay, I think we can, by the way, because the constraint is just evaluated, right? But yes, but I can get back to you on that, right?
okay, great. Thank you.
So, so let's say you have a column in your table which is marked reservable, and the quantity, was 100, right? So what we do, we have this data structure called the escrow journal, where we escrow, um, you know, these values. Hey, that the committed, like value for this column, is 100, and available is 100. Okay, we start with this state. So now transaction one comes in, it does an update where it reduces the quantity at hand to quantity at hand minus 50, right? So what we do is, so we check the available, value, and we would just subtract it, with 50, right? And that's okay to do because you had that, quantity available so far. Now when transaction two comes in, which tries to reduce this quantity at hand, by 30, it's still okay because you had 50 available. So now it goes down to, 20. And once this transaction commits, right? So we actually update the column value, to 70, right? Because again, the actual, like the actual quantity which has been committed, is only 30, right? Not this 50. So that's why it goes to 70. But your available, is still 20 because the sum of all your, uncommitted and committed transactions is still, less, right? Um, and you have transaction three that comes in, which would like to update the quantity, by 50. So notice over here that even though, in your committed values, you still have the quantity and had as 70, but the database would reject it because your available is 20. Because there is a transaction one which had reserved, this quantity of 50. But even though it's not committed yet, okay? So we would, fail the update statement, and we would, roll it back. So then when transaction one commits, we would reduce, like both of these, to 20 and 20. So if now in the future someone else, like wants a quantity of 20, right, they can get it. So notice that, hey, that we have two states, right? We are keeping, track of committed data, and we are also keeping track of the available, which is nothing but your uncommitted, reservations, and your committed reservations, both, for which we try to, fail your updates early on, but we keep track of your reservations, right? And the syntax that's there. So we have, like in your, create table statement, you can have a column with the reservable constraint. Uh, so you have a reservable, keyword to mark that, hey, this specific column is reservable, and you have, this check constraint where you can check the balance is greater than 0, right? Which is optional. And we also have other DDLs like alter table, which can allow you to add a constraint, and the reservable property, later on. Okay. And with respect to the performance,
So that's one more question, actually. What happens if your update actually has a where clause which says something along the lines of, hey, I've only updated if I have more than, so if it said I will subtract 20 in the previous example, the last transaction 2 or transaction 3, right? What if there was a where clause within that transaction where it said I'll update it if it's greater than 20? And
Yeah.
it's only subtracting 20. In that case, it should be able to go through it, but only if it's greater than 20. And so your available is not greater than 20, whereas your committed is. So which one does it check?
Yeah. So since it's a reservable column, right? We would consult the escrow journal. Okay. Even though you have, any where clauses, right? But we respect both, right? So we'll respect the where clause, like, and the escrow journal. It's not or, it's both of them.
I see, I see, I see.
Yeah.
Thank
So
you.
we make sure that, hey, that you cannot bypass, our mechanisms.
I also have a question. Where is the lock-free here? Is it like, because surely you have protection on the journal, right? So like surely
Yeah.
you have locks on top of that, and also in the transaction layer. So is there more that you're coming up with?
Yes. So we have locks on the escrow journal, but notice that, hey, that lock, right, is taken and released immediately, right? So it's like a, like latch, like how we implemented it internally, you know, So it's either in memory or it's a table, right? But notice that as soon as we would decrement, the quantity, which is over here, right, from 100 to 50, right, we would release the lock. We don't hold this lock for the duration from the time of the update to the commit time, right? So that time, by the way, between the update and the commit, since we have interactive transactions with the application, could have been doing anything, you know, okay. And notice that it's over the application network, which can be on LAN or whatever, right? So it takes, the roll lock for a very long duration, right? So that's the problem, which we fix through, by just decrementing this quantity, and, and release the lock on that quantity field.
Thank you.
Great. And I hate to say this, but we will lose the room in 22 minutes.
Yeah. So let me,
And
okay,
I know
move
we've
on.
been slowing you down, so apologies for that. This is
No
interesting.
problem. Yeah. Yeah. So let's move on, right? So yeah. So we notice, like performance, improvements. So we did a transaction throughput, like runs, and TPCC runs, we have noticed, like quite a significant improvement. So 50x, right? So this is the maximum value, by the way, right? So 50x, like on the update throughput, where some of the, like rows are locked and, you know, and those are being updated, like by a lot of transactions, and all of them are holding these locks for a long duration, about 50 milliseconds, all of the transactions. And on the right-hand side, it's 8x in transaction throughput improvement, on TPCC, which is done over like multiple data warehouses. So, okay, so I'll keep it short, and hand it over to Akshay for
Hey.
sessionless transactions. Right, go ahead,
Yeah,
Akshay.
I'll try to cover the uh two parts that I'm presenting in like the next 20 minutes, okay? But feel free to interrupt me if there are any questions. So the first thing I'm covering is the sessionless transactions. So it's the you can say it's like transactions for the sessionless world. So Kishi briefly touched upon it, right? Like usually our transactions are like for complex OLTP workloads and they're interactive transactions. So like if you think about it, a typical transaction would look like something like, hey, you update the audit table saying that, hey, you're going to log this operation. Then this is a typical, like, let's say if you're doing some balance transfer, then you log the source account and the destination account rows. You basically then select an account for the balance on the source side, select an account for the balance on the destination side. Then probably in step 5 and 6, you're running some business checks. And then again, like after you're done with your business checks, you will update the source, update the destination, then commit the transaction. But if you notice, right, like step number 5 and 6 are not our application side logic, right? They are not technically like the database side logic. You're doing some application level thinking over here, right? Uh, so so in interactive transactions, the issue that happens is, right, like you have started a session and now you're holding on to that connection, like the database connection, for a long time, right? And then that connection can have like a pretty low utilization, as you saw in the previous step, like if there is a lot of application think time, right? And this connection then cannot be shared between like uh between your current transaction and any other transactions, right? And sooner or later, right, you have limited connections and your database instance will, run out of connections. So one way to handle this is XA transactions, a popular distributed systems protocol. Like what you can do is you can use XA transactions, to suspend a branch, that particular branch, right, once it's done its unit of work. And but the problem here is what that involves is like you'll have to have something like an external transaction manager in order to coordinate your in order to coordinate your XA transaction. Now what happens, like if your transaction manager fails, then yeah, you're going to have some logs that are held in your database side, which can then lead like, like to cascading failures like down the line. Plus also like with XA transactions, what happens is now you have a transaction manager, and now also the complexity of handling your two-phase commit protocol, it's passed over to your application side, right? So nothing in the database side is like handling that solution, right? So XA transactions is the potential solution, but there are certain limitations over here, right? Uh, so the solution that we have come up with is something called as Oracle Sessionless Transactions. So what you do is like with a sessionless transaction, the transactions are basically database coordinated, and you have the ability to like suspend, resume. You have the ability to either suspend a transaction or resume a transaction. I'll go through it with an example. Uh, the locks and everything and all the complexity is managed on the database side, and the application does not need to perform any kind of like pre-validations or validations, right? Uh, the when you suspend when you suspend the branch, the database connection is released and it can be used by any other transaction. Okay. So this also increases your connection this also increases your connection resource efficiency, right? So going back to the previous example, your steps 1, 2, 3, 4, right? Where you're like updating the audit table, you're locking certain rows on the source and destination, you're updating the balances on the source and destination. That can be done in your session one. You start a sessionless transaction and then you suspend it, right? Uh, then you run your business logic on your application side. And once you're done with that, you can come back in a different session. You can resume this sessionless transaction and then you can issue a commit, right? So that's basically sessionless transactions. Uh, yeah, and when you're basically suspending your transaction, you're basically giving away your connection, and some other session can pick, but the same session can be then used by some other transaction, right? Uh, so the idea with sessionless transactions is, right, you don't need any XA protocol. You don't need an external transaction manager because all the complexity is handled inside the database. You don't need any you don't need the transaction manager for coordinating any two-phase commit protocol, and plus you don't need any extra complex recovery mechanism, right? So the basic idea is you're multiplexing transactions and sessions inside the database, right? So basically, if you look at a single DML flow over here, right? When you're using XA, right, you have to follow that protocol where you like do a XA start, then 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 basically once you have done your XA start, then is when you execute your DML. Then after that you do XA end. That's when you detach the session, and after that you can go ahead and commit your transaction, right? Whereas in sessionless transactions, it's simple. Like you basically just issue the DML with an auto suspend option, and once your DML is executed, your session is like kind of suspended, marked as suspended. Uh, so basically, if you see like there are like three RPCs on the XA side and sessionless transaction just as a single RPC. Uh, Also, like when you come to the commit protocol phase, like you have to first execute like as an external transaction manager, you have to execute the prepare phase, and once you're completed with the prepare phase, then you execute like the XA commit, right? And here, if you see like this I'm talking about a read-only optimization where like the second instance branch is only doing a read-only. So in the commit phase, the you're not waiting on the second branch, yeah. Whereas in sessionless transactions, if you see, right, when you issue a commit, your database, your basically commit is managed on the database side, and the database manages the commit and prepare phase, and then you're returning back the committed transaction to the client, right? So since it's internally managed, right, like you're not spending a lot of time connecting between the client and your database connections, right? So you're also reducing your latency on that part, right? So to quickly go over an example, this is an example where like yeah, you get a session, you get a session, you start your transaction, you issue a prepare statement, and then you suspend your basically you suspend your session. Then uh, then on a different connection, you can basically uh, resume your transaction, execute a different statement, and then close that second connection, right? And then finally, you can again come to your previous connection. You can resume your transaction. You can issue You can execute your statements and then finally commit the transaction and close your transaction. Yeah. So any questions with respect to sessionless transactions?
What's the semantics when the transaction resumes? Like, uh, it may have read something that's modified, so it's going to get consistent read semantics, or what does the overall transaction semantics look like?
The transaction semantics will be like consistent read. So yeah.
Okay.
If you was yeah.
I have a quick question.
Okay. And yeah,
How does
there
this
was one more question.
how does this interact with connection pooling?
Sorry, I can't hear you actually.
The question is, how does this interact with connection pooling? Like we're using connections.
It's not
Connection
clear.
pooling.
I can actually take that up, right? So the question is that how does this interact with the connection pooling,
Exactly.
right? Yeah. So as you can see, right, that over here, right, the session and transactions are being multiplexed. Okay. You can have like any number of connections, okay, on the client side, which are connected to, some dedicated sessions on the database side, but you can multiplex transactions over here. Okay. So with respect to connection pooling, right, nothing changes, but it's just that, hey, that instead of needing more connections, for running, let's say, I guess more number of transactions, right? So you don't need that many sessions, right? So you can just multiplex, if you want to run like 10,000 transactions, and so you can just multiplex those transactions on like, I don't know, like 100 sessions, right? So that's the value that we add over here, right? But yes, but connection pooling, so all of that, like doesn't change.
Got it. Thank you.
Another quick question about the example code is, sorry, can you hear me by the way?
Yes.
Yes. For the example code where I see you obtain a GTR ID. So if I were to take my GTR ID and to give it to someone else on a different machine, they can continue my transaction for me. Is that how I should think of?
Yeah.
Yes. Yeah.
Okay.
Yeah.
So you
Yeah,
can
this works on rack. Yeah.
Yeah, so as a client, by the way, right, you can pass this GTR ID, to other clients and they can even continue it forward, right? Which is where we add value, by the way, right? So we have, like decoupled, your transaction from the session, right? You can give it to a different session, and they can resume your transaction, right? Which is what XA used to do, in some sense, but we took out all the complexity of XA from here.
Cool. Thank you.
Yeah, and then moving on to the last topic, I think
I
Kishi
had
briefly.
one more question on the. So how expensive is suspend transaction, and is it kind of what's the order of magnitude? Like does it depend upon how many operations have been done, how many locks been acquired, or something like that?
It's basically just detaching your session right from the
System.
from the transaction, right? So essentially, like when you come in later, you want to attach that transaction back to a different session. So I think it probably depends on the order of like how many transactions you have active in the system, right? The
I
complexity.
can add, like to that a bit, right? So if you
Yeah.
notice, right, that in Oracle, right, the way transactions are implemented, right? We have some, in-memory state. We also have on-disk state. Okay. So the on-disk state is the rolocks, right? So since our rolocks are already on disk, right, we don't have to, like close them out or like, like spend some CPU effort to actually, to persist the rolocks since they're already persisted, right? So that takes care of the rolocks part, right? But the in-memory state that we have, we keep some state for the transaction, the session as well, I mean, since we have some cursor, in Oracle, we have some cursor metadata as well. So some of those things, like we had to persist, right? So there is new infrastructure, like for persisting, some metadata, right, of the transaction, right? So there is some overhead of that, of course, but from our runs, right, we have not found out any significant, overhead of that, other than the writes that you have to do for persisting that, which is constant more or less. It doesn't depend on any number of row locks. So I hope that answers your question.
Yes, it does. Thank you.
Cool. Yeah, so the final topic is I think Kishi briefly touched on it when he covered the duality view replications, but it's basically the value-based concurrency control. It's an optimistic concurrency control method based on the values in the data, right? So looking at an example, right? So let's say I have a select statement followed by an update statement, right? So I'm basically selecting a balance from accounts for a particular customer, and then I'm updating the balance. Now, what happens if like between the select and then update, I have a different transaction that comes in and then updates my balance? This is allowed, right? Like because we Oracle follows the consistent read semantics, and in consistent read, we are not taking any read locks, right? So the balance can be updated, and then basically like the your current transaction is kind of not in a good state because now the balance has been updated by some other transaction, right? Now, this can be easily solved by adding an update. So what you can do is you can do a select for update. What that does is now you'll basically take a read lock when you perform your update, and and if there is a different transaction, that transaction will wait on this lock and will wait for this lock to be released. Which that what that means is like it can only acquire the lock once the transaction one is committed, and then like perform its activities. So, but this is kind of like a pessimistic protocol, right? Where we are acquiring rocks upfront and you're holding it for the entire duration of the transaction. So you basically have like locking overheads, you reduce parallelism, and this can like call like has the potential to cause deadlocks if we don't carefully manage this, right? uh, so what we have done is we have introduced something called as a value-based concurrency control, and the way it works is like in the HTTP protocol you have like tags, right, which are like like which kind of are like the signature for the contents of the web page, right? So what Oracle has done is Oracle has extended this concept to our core database side. Okay, so we are what we are doing is like whenever we are reading rows from the database, we are associating an tag with the rows. Okay, and the way it is done is right. The tag is computed using an hash. So you can basically select the columns of interest for a particular row, and then you reorder the columns in like a alphabetical order. You compute a chained hash, and then this is your kind of the get that 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 Kishi had also talked about, right? So you read the rows with an tag, and then now when your application has modified those or changed those rows, uh, when it is trying to update your database, it will again compute the tag, and it will update the rows only if the tags match. If basically if you're right and basically when you were reading your tag, basically when you were reading you had a tag, in your writing you also computed the tag. Only if the computations match, only then can you go ahead and update the rows, right? So if some other user has changed the data, your write operation will be rejected and your transaction will be rolled back. Yeah. And then the write again, then you'll have to try it out by giving it basically the new data plus the eta. Yeah. So this is like like basic the optimistic concurrency control. And the way, so in my previous example, what you do is like along with the select balance, you will pass in the sys row tag, which basically reads the tag for the relevant fields. Okay, so this can be computed at a row level or like for multiple rows, right? And even for a single row, you can also select the columns which you're basically updating, right? So there is no need for you to acquire any read locks, and the only at the time of the update is when you will be acquiring any write locks to update the values. So this is great when you have application think time again, right? So between like you read some data, you do something in the application side, and then you write it back, right? So this is great for this. And specifically, what I would like to mention is like a single row, like the example I presented here is like just updating a single row. And for a single row, yes, you can probably solve this problem is this where you're selecting something and they're updating something afterwards, right? You can pass in a predicate saying that, hey, I will update if the balance is only this, right? So that's easily solvable for a single row. But the main power of the C tag based is when you have like multiple rows, right? So in this case, right? So we are computing the aggregate E tags, right, for multiple rows, and then we are only updating those rows if we notice that the write time E tag is matching the E tag that you computed during the read time. So basically, this is the true power of this solution. Uh, so yeah, that's it for this value-based concurrency stuff. And do you have any questions, folks?
Yeah, no, this is good. So essentially, sometimes the optimistic concurrency control protocols will maintain a read and write set automatically in the background. Here, with the E tags, you push it out into the application layer. And so the application layer, effectively, are getting check that the read set hasn't changed between
Yep.
the first part of the transaction and the final commit stage. So that makes sense. Cool.
Yeah.
And that would be the right way to understand this, right?
Yes.
Cool. That's
Yes.
neat.
Yeah.
Yep.
Yeah. So
Okay.
yes, and finally, yeah, this is like the different areas that our team works on. We work on distributed systems, we work on database technologies, storage systems, operating systems, and of course, like data structures and algorithms. So any of these, this is our software tech stack, and also now newly like the data and AI tech stack. We're exploring how AI technologies can be used in the database. And so if any of these fields interest you, which I believe like since you are attending this seminar, I'm pretty sure like most of you are interested in uh, a few of these fields. So please feel free to reach out to Kishi or I, and feel free to apply to roles in our team. Anything else, Kishi, that you want to add?
Hey, Akshay, I had a quick question on the E tag.
Sure. Okay.
So,
Let's do
Prakash,
that.
we may have to take that question offline since we are
Okay.
getting kicked out of the room in like 30 seconds.
Okay.
So, if you don't mind, you could just email Kishi and Akshay about that. So, Kishi, Akshay, I really wanted to thank you
So
for taking the time to talk to us. This was great.
thank you guys.
Thanks, guys, for
Thanks.
having us over again.
All
Thank
right.
you.
I'm going to sign out from here and then we'll see you guys soon. Bye.
Okay, we'll see you. Bye.